Hey everybody, so today I want to spend a little bit of time and talk about disk partitioning, disk management, and a couple of things in that area. So when we were talking about NFS on the Wednesday before spring break, we did get into a little bit of the mount FS tab kind of things, how you would mount a file system, in that case a remote file system. But in this instance we're going to actually look at physical disk devices. So these would be hard disks that you plug into a computer, a server, or something like that. Or in this case, a virtual device that you attach to the VM. So what we're going to do today is we're going to go through, we're going to look at that. We're going to use fdisk, a utility to manage partitions, to actually partition out that device. We're going to look at how you would create a file system on those devices. These operations are something that are a little bit less complicated on Windows, that are a bit more challenging on Linux, but it's definitely important information to know. So in order to do any of this stuff, what we really should do is add another disk to our VM. So when we're doing this, we're going to not only add this disk for, I guess, the lecture, we're also going to probably have a lab on it coming up soon. So just keep that in mind. So I'm just going to go through, I'll do it in real time here, adding a disk in at least workstation. If you're using some other software, you're going to have to figure it out. So you go to VM settings, then click on add hard disk. So for the purposes of this demonstration, I'm going to use SATA. When we use SATA with a VM, and it's in the Linux environment at least, that disk will immediately automatically be detected. If we use the SCSI disk, we'd have to go through a few miscellaneous steps to get it to be detected. We might have to reboot the VM. But if we use a SATA disk, again, that should be detected immediately. Let's accept the defaults on that page. So I'm going to change my maximum disk size down to 0.5 gigabytes, so it should be 512 megabytes, just because we're not going to really put any information on the disk. We just want to have something that we can look at. So go ahead and hit next. Click on through that. Looks like everything went well. Okay, yep. So let's go ahead and look at the very basics of an fdisk output. I would say fdisk L, disk L. We're going to need root permissions for all of this stuff. Fdisk L, and that would show me all of the devices that I have. We can see we have a bunch of RAM devices. We're not really going to get into that very much right now, but we do have a couple of interesting disks here. So this is our primary disk right here, is dev SDA, and then it has a number of partitions here that are listed. So we have a partition which contains a root file system and everything like that. And then the other partition that we have that's kind of important is the swap partition. And on the swap partition, temporary data goes there. If you suspend your computer, the suspend information will be put on the swap partition. If you run out of memory, the kernel will start allocating memory from disk space, and that's another component of the swap partition. So we have a number of partitions here. They have different numbers. They have these file names. So again, remember, in a Unix environment, everything is a file. So if I went and I look in dev at dev SDA star, so you can see we have a number of devices here. So dev SDA, it corresponds to the actual disks itself. So all of the partitions 1 through 5 are all part of this dev SDA. So at the very beginning of the disk, there's actually a little bit of metadata data about the data, and then we actually start the partition table. And that's where these come from, the actual data itself. So you can think of, there's a little bit of a header, and then all of these are contained inside of dev SDA. So from a user standpoint, if we're looking at mounting a particular partition, we look at the fdisk output to get a little bit more information, or we could just look at dev SDA, or whatever we want to look at for more generic information. So when we're looking at disks, we have a couple of different components here. I should talk about that, I guess. So what we really have is two variables when it goes into disk names. We have SD, so storage device, and then a letter. So let's call that I. So we have I, which is the number of the disk, and we have N, which is the number of the partition. So there would be a disk SDA. SDA1 would be partition 1, 2 would be 2, so on and so forth. And that's generally straightforward. Now, there's a couple different environments which you might encounter that don't follow this SD naming scheme. One of the ones that I've seen was a virtual server. So in that case, it was a VDA instead of SDA. But generally speaking, it should follow something along those lines. So I have my primary disk here. I have another disk that I was testing this lecture on, and I have this final disk which we just made. So as you add disks, they'll have new names like this. One thing though that you might run into is if you create a disk, you attach it, you delete it, and you create another disk and attach it, your names might end up getting off. And we'll look at how we can work around that when we're setting up persistent mount points. Occasionally when you have multiple disks, they'll actually get out of order, and so we can't necessarily rely on these names. And we'll talk about how we can, again, work around that in a moment here. But for now, let's look at how we'd actually go about partitioning our device. So in order to do that, let's just again look at our device that we're looking at right now, our disk that we just added. So we'd say fdisk-L for list dev sdb or sdc. SDC, and that would show us just that information. If you left off the actual path of the device, you'd see all of the information for all of the different devices. So I'll just say fdisk dev sdc to actually enter an interactive prompt, and now we can enter commands to manipulate this disk. So we just created this disk, there's absolutely no data stored on it, and there's a couple of things that we're going to need to do to actually be able to use this disk. So I'll just go over that really quick. The first thing we'll need to do is create a partition table, then we'll have to create a partition on that partition table, create a file system on that partition, and then mount it on the file system somewhere. So at this step, we're going to do two of those things. We're going to create the partition table, and we're going to create a partition. So we can push M really quick here for help, and then we need to choose one of these things to do at the very bottom. So there's really two different partition tables that you see often. There's a GPT partition table and there's a DOS partition table. So there's a couple little minor things that go into the differences between the two partition tables, but the big thing is a DOS partition table, the partitions need to have a type. You can only have something like 4 primary and then an infinite number of extended partitions. But with a GPT, there's no type, and you can have as many partitions as you want to. So for the purposes of this demonstration, we're just going to use GPT because it's a little bit more straightforward. So we do that. It will create that new partition table, and then we can go and we can add a new partition. So let's go back a little bit. Let's say we wanted to look at our partitions. We could just say P. And then right now there's nothing on there. Saying P in this interactive prompt would give us the exact same information as the fdisk-L had earlier. So let's just say N for new partition. Now we can have any partition number. I'm just going to say 1. The first sector defaults to the very minimum the first sector on the disk, basically. So you can see the first sector is 2048, and like I was saying before, there's that header before that which contains metadata about the disk, and it contains the partition table itself. And then we specify the last sector. So the default is the entire disk, or we could say something like plus like 100 megabytes or something like that. And what that would do is it would go from the first sector, so our default of 2048 or whatever we specified there, and it would add 100 megabytes to that number. And you can see here you can do kilobytes, megabytes, gigabytes, terabytes, and petabytes if you wanted to, if you had disks that big. But we're just going to accept the defaults, and we're going to allow the disk to expand all the way until the end. So we hit that, and it is all done. So we hit P to print out the partition table, and we can see we have a new partition right here, dev SDC1, and it looks like we're all ready to go. So in order to finish out this process, we enter a W for write, and it will write that partition table out to the disk, and then it will try, you can see there's two things that are happening right here, calling IOCTL to reread partition table and syncing disks. That means that fdisk is trying to update the listings in the dev directory. So if it didn't do this, we might have to reboot. We might have to call some this part probe program. Which would also update, would sync the changes from any partitioning program to the operating system itself. So let's say I did LSL and dev SDC. We can see we have two new disks that, well, we have this one new partition, and we have our main disk device right there. And that was the partition that we just created in the last step here. So if I went and I said fdiskl, again, we see the same thing that we just saw there. So we have this partition, and there's no data on it currently. So normally what we would do is we would just say mount. Remember, we should remember this from before. We'd say mount device name and then mount point. So I'm just going to go over to temp. I'll make a mount point really quick. No, I'll just use the mount. We have this mount here that's empty right now. Remember, a mount point is just a folder, so to make a mount point, you just say mkdir mount. That's odd. It just died on me. I'll go into temp. What in the world is that? It's just dying on me. It just, when I type mount, that's so weird. Look at how odd this is. It's just the terminal dies when I try and make a directory. I just have the absolute worst luck with computers, I swear. Anyway, we're kind of getting off topic right now. So, things we've done so far, I'm just going to try and work through this. I don't know if I can or not, but we'll see how it goes. So we have our partition table, we have our partition made. Now we need to format the file system. So in order to do that, we use the mkfs command, and then dot, and then the file system type afterwards. So there's a number of different file systems we can actually use. The most common one is ext4. But there's also ones that you're probably familiar with. There's FAT, there's NTFS, things like that. And there's a number of other file systems that are actually available to you. Now, most of these file systems have been around for a very long time, and there's a lot of new modern file systems that have features that are very interesting that have been coming out recently. The one thing that I'll point out is kind of the benchmarks on file system performance. So you can see perhaps with certain applications like SQLite, an NTFS file system might not perform, or might perform the best in this case, and a Btrfs file system might perform the worst. So it's kind of up to you to figure out which file systems you want to use. Now, ext4 is generally seen as just a good mid-range choice for at least Linux. NTFS is still very prevalent in Windows environments. So in this case, we're just going to select ext4. So we say that, and then we say the partition that we want to format. So we say dev sdc1 to format that new partition that we made. We don't do this, that would not work. It would delete the header information for the file system. We want to just format this one partition on the disk, not the disk itself. Oh my. Oh, okay. Okay, give me 1 second. I think I need to reboot my VM. This is not something you should have. Oh my goodness. This is not something you should have to do. But I think I might have when I was setting things up, I think I remember this. I think I might have accidentally removed my primary hard disk, which would end up in things being really, really broken. So let me see. Maybe I didn't actually delete it. Okay, I'm gonna try and power back on, and hopefully it's still there and not broken. Yeah, that's funny. Okay, so I think we're back here. Now I should be good to go. So again, what we're gonna say. This is sorry to always get off. I'm always getting off task for some reason. But we're back on here. So again, what we're gonna say is mkfs ext4 dev sd c1 to format that new partition we created, and that will actually format to the partition so it can be used to store actual information. So now that we've done that, the final step that we have in this process is to mount that partition somewhere. So we say mount, we say the device name, SDC1, and we're going to mount it on mount. And we cd into mount, and then we can store whatever information we want to on the disk. It's all ready to go. So yeah, that's pretty much, I think, relatively straightforward and how we do all of that. The only other thing to note, I guess, is you have to also unmount disk. We don't have to. It's just good to do so. So you can say umount and then the mount point, and that would unmount the disk. So let's look at the fs tab file really quick. So we talked about this before. This is where our persistent mounts go. So let's say we want to persistently mount dev SDC1 on a mount point. We need to go into this file and actually set it up. So you can see, well, we were talking about this earlier, this problem where partitions kind of get moved around. There's this UUID which helps us alleviate that. And we'll look at how we can mount a partition like that in a little bit. So really the two ways we can do it is we can mount a partition by a device name, or we can mount it by a UUID. So we're going to start out by mounting it by a UUID. I'd just say dev SDC1. I'll mount it on mount. Type, we're just going to say auto. I guess we could explicitly say ext4, might as well. And then we'll say just defaults, so the default options, and then 0, 0 for these options at the end. No commas there. So after we've done that, remember that partition doesn't get mounted automatically. The one thing that I don't think I noted before was you can actually run mount-a to look at the fs tab file and automatically mount the partitions found in it. I messed something up here already, of course. SDC mount extent 4 defaults plural, of course. Mount A, that's up. We look at mount to see all of the mounts, and we can see dev SDC on mount, and then some other attributes here that we're going to talk about in a second. So if I go over to mount and I just echo ASDF into file, we can see that the file is created and everything was straightforward like that. So another interesting command that we can look at, we looked at mount already. So mount is the command that if we run it by itself shows us all of the things that we have mounted. So we have the device mounted here, type this. Another way that we can do it is by using the df command. So we can say df. This is also a little bit more interesting. It shows us more information that's perhaps nicer. Not only does it show us the file system device and where it's mounted at, it shows us how much of the file system is actually used. So this is a percentage right here. One option that's useful for df is the -h command or flag, which will show it in human readable format. So it will convert these bytes, I believe, that are into megabytes, into gigabytes, into just nice readable formats. So I definitely recommend using the -h command. Another one that's useful is uppercase T. That will show the type of the device. So we have this ext4 device. That's our primary one. We have the cxt4 one here. That's our one that we just created. And there's another file type that I'll come back to and talk about after in a little bit here, tempfs. So that's actually a file system in memory, and we're going to come back to that in just a minute to talk about it. So gonna kind of finish up this physical disk stuff, talking about those UUIDs. So let's take a look at FS tab one more time. So let's look at where these UUIDs actually come from. So we have this UUID right here. This is for dev SDA1, our primary partition that has all of our operating system information on it. So what we can do is run blkid on dev SDA1, and hopefully the UUID that is given by this command will be the same as it is there. So we do, it is. So when we run that command, we get this UUID back. And this UUID can be copied right into this file, and it will run successfully. So let's do this. Let's take this dev SDC1 and change it out for a UUID. So I'm going to say blkid dev SDC1. I'm going to copy this. I might have to remove the quotations. I don't recall offhand. Let's see, FS tab. We'll try and run mount A to update it. And it looks like it ran. So we'll cd into mount really quick. Just file to see if that worked. Yeah, it looks like everything works fine. Cool. So that's how you change it to UUIDs. Again, remember that's because these A, the C, the B might get reordered. And as if you're using UUIDs and somehow the disks get reordered, it will still mount the same partition. This UUID will be the same regardless whether it's SDA1 or SDC1. So that's again something you might run into that you might have to deal with. So let's go back. Let's look at the options on the FS tab a little bit. So we're going into this file. So I just took defaults. So you can look at what defaults might be different for different file systems. So I'll just say mount, and you can see these are the options for these are the default options for ext4. So there's read write, that's what that stands for. So read write, and then there's rel a time, which is talking about how the access time will be created or entered on files, and then I'm not exactly sure what that does. So let's talk about read write. Let's talk about the access time component of it. So I'm going to go over here to mount, and if we go LSL, we can see that there's actually this access time that's stored with these files. So you can see right now we were just creating these files a minute ago, and their times were being updated as we were going through all of this. So if I was to edit this file, add some content, you can see that that time would actually be updated to the current time. Now I feel like there might be another time that I feel like there's a access time, there's a modified time, and there's a created time, forget exactly how to do that. I'm gonna look it up really quick here. Yeah, there definitely is. Yeah, so okay. So if you go and you do ls l and you say time equals a time, so it's for access time, it will print when the file was last accessed. So if I just accessed it there, we can see that that time was updated. Now that's not the default time that's actually specified. I believe it was the modified time that's specified by default. So if I change that to M time, that's when the file changes. I guess on this particular file system we can only do A time and C time. So we have access time and created time. And that would tell us when it was created. And again, A was accessed. So going back to mount, that was an option actually of ext4 was rel A time. So it's actually going to store the access time. So one of the things we can do is actually turn off access time modifications, or updates I should say, read write, and then we'd say no A time. And that would prevent the access time from being written out to the disk every single time. Now the reason this is kind of important is you don't you in some cases don't want the disk to write out every single time that you update something. Let's say you're on an SSD and you only have 100 million read writes on a particular block or something like that. You wouldn't want to waste out like a large number of those just writing out access time. So a common thing that you do on SSDs is actually turn off access time updates. So I'll say mount-O, and I think I might mount-A to do the etcfs tab, and I might actually have to unmount the mount first. Yeah, so I'll have to unmount umount mount. I'm in the has in the mount point right there, so I have to go and unmount that. So then we'll do mount A again and to process the FS tab, and now we can see we have no A time there. So the access time isn't updated every time that something is accessed. Still is updated when something is changed, but not accessed. So the other option that we're going to look at right here is read write. So it's mounting the disk read write right now. So FS tab, we can change that to read only actually, RO I think. And then it will mount it read-only so we can't make changes to the disk. So we'd say umount, mount A, and then we say mount to look at our disk, and now we have read-only. So if we go over to mount, and we kind of try and touch file 3, it'll say read-only file system. If we try and echo ASDF in file 2, obviously still read-only file system and is not going to work. So, one common thing you might encounter is a read-only file system that you need to actually remount as a read-write file system and make some modifications on that file system. So we can actually do that in real time with the mount command. So we say mount-O, and the first thing we say is remount. So that specifies that we are remounting an already mounted file system, and then we can say read-write. And then we can say the mount point. Now if we look at our mounts again with mount, we can see that instead of having a read-only file system, we now have a read-write file system. And we can go and we can make files and everything just like that. So after you had finished with your modifications and you wanted to reset that back to a read-only file system, you could just say again the same command, then remount read-only, and then if I went and tried to create a file again, you can see it's back to being a read-only file system. And again, the important thing to remember is whenever you change something with mount, you mount a device on a mount point, you remount something, as those changes are not persisted over reboots, and the only changes that are persisted are the FS tab changes. So something you might want to get into the habit of doing is changing things right away at FS tab, and then saying mount-A to process the FS tab and actually do the changes, because it's probably it's just a better way to get into doing it. So I think the final thing that I wanted to talk about today was that tempfs stuff that we saw earlier. So remember we were seeing this tempfs. We saw a bunch of different file systems are actually mounted as tempfs. And again, what that means is all the data stored in that file system is stored in memory. So there's no disk that's actually backing that, it's just files stored directly in memory. So let's go ahead and we're going to make a little tempfs. So I'm going to actually unmount dev sdc1, and then we're going to use the mount command to make some tempfs. So we're going to say mount, and we say type tempfs. Since there's no device that specifies which file system types are contained in it, we're going to need to specify which type it is with the -t. And then we say oh, and the main option that we want to look at is the size option. So we say size, we'll just say 100 megabytes right now. And then to follow the syntax of the mount commands, we still have to say tempfs in the device name. That's where the device would usually go, since it's tempfs backed by memory. We're just going to put that right there. And then we're going to create it on mount. Now we can cd into mount. And just like before, I can create a bunch of files and stuff. And there we go. So that's pretty straightforward. The one thing to note is there was no device backing it up, no file system type aside from tempfs. There's no formatting of the tempfs partition. It's just kind of magical in-memory space that you have. So again, recall though, since it's in memory, if we go and we unmount it, and then we go and mount it again, that's no longer there, and it's just disappeared. So that's nice. A lot of the times you'll see the actual temp. So there's a reason. I guess there's two reasons it's called tempfs. It's temporary, and a lot of the times temp is actually mounted as tempfs. So files that are stored in temp are actually stored in memory. So we can figure that out. We could say mount and grep temp to see if it's actually mounted as tempfs. And in this case it isn't, but on certain other distributions it might be. So if you're storing things in temp and you're rebooting your box and you're like, oh, where's my files going? It's because it was mounted as tempfs. Or it could actually be stored on the file system but cleared out by the distribution on every boot. So that's how that one would go. So let me look at my list here really quick again, see if I missed anything. So the one final thing we talked a little bit about was these two different types of partition schemes. We just noted them. There's MBR and there's GPT. So fdisk, if you're working on an older distribution, might not have necessarily had support for MBR partitions, and you have to use a utility called cgdisk to actually manipulate them. So fdisk has added GPT support recently, which gets you around those issues. And you can just use fdisk for everything, for all your needs. But if for some reason you open up fdisk and it's like GPT partition table not supported or something like that, you can just use cgdisk instead. And the syntax is fairly similar, so you just say cgdisk dev sda or sdc1. And in this case, it only works with GPT disks, so it's warning me that if I do change anything, it's going to die on me. And the GUI is actually a little bit easier even. I mean, you just say new, first, size, things like that, and then you'd write if you wanted to write out your changes. So it's pretty straightforward, I think. So yeah, that's all I have for you today. You should see a lab working with basic disk stuff, hopefully coming up here in a few days. So class is also canceled on Wednesday. I don't know if I'll have time to make a video for that class. If not, then you'll just have some additional time to work on the lab. Alright, thank you. Bye.